Alright guys, now we're to the good stuff. I'm kidding, it's all been good. This is even better. Arrays. What an array is it's a contiguous series. Pieces of data. And we've already been dealing with arrays even though we didn't know about it. A string is a series of characters. Anything that is a series can be stored in an array. Like if we wanted to put all these words up here from whoever did this, we could say that this is going to be added to the array, that's going to be added to the array, and so on all the way down until the last one. Now the way arrays count is they start with 0 rather than 1, which is why I have this, the silly habit of giving an assignment 0 to kind of hammer that in. So this would be element number 0. Element number 1. I'm putting square braces around it for a reason because that's how in C++ and Python and Java you reference specific elements. And so this would be 6. Hope this person doesn't mind. I better erase all this. 7. 8. Okay, so now we have an array that is 9 elements long. Where did I get 9 from? Well, because you start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8.
You start at 0.
Yeah. And if I had counted this one as 6, then we'd have 10. 7, 8, 9. Let's do that again. Humans count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of this array is 10 elements long. And when we processed it, we processed it with some kind of loop that counted from 0 to 9. A for loop or a while loop or something like that. If you try to access past the end of an array, if you try to access element number 10 or -1 or something like that, at best the computer will throw an exception and the program will stop running. And what I mean by at best is that if you try to access past the end of the array, that might work. It might look like it's working you, but you're overriding random parts of memory in your computer or in your program. And attackers can use that to penetrate a program. It's called a buffer override, which is when you let the user put too much data into an array and you're writing past the end of the array into other variables or other data segments in your program.
Sorry to interrupt. Are you recording this?
Yeah, I hope so. Yes, indeed I am. Thank you for asking. Okay, so that's the idea behind an array. The only thing missing from this is I didn't give it a name. We have the counters, but we didn't have the name. So I'm just going to use like W. That would have been W. I'm calling it W for words. W's sub 0, W subscript 1, W subscript 2. W subscript 3, W subscript 4, W subscript 5. So when I wanted to reference an element, I could do cout, arrow, arrow, W subscript 2, and then end line. And then what it would happen is it would send to cout, W subscript 2. This is called the index number. This is the array, this is the index number. 2, W subscript 2 is the word research. So when we executed that line of code, cout, W subscript 2, it would print out the word research. Now some other languages have some neat things to do with arrays that C++ does not. C++ is a little bit more old school. In C++ you cannot query the array to find out how many elements are in it. So you have to keep track of how many elements are in it. And what I mean by that is I can't just programmatically ask the array, oh, by the way, how long are you? What's your size? And it'll say, oh, 10. Now you know what what your limit is for your while loop or your for loops. You have to keep track of that separately. Not that that's a disaster, it's just something that's made a little bit easier in other languages, like Python and Java. So arrays hold multiple values. What is an array? It's a variable that can store multiple values of the same type. Here's my goofy explanation of an array. An apartment complex with rooms, with apartments 0 through 99. You have 100 different households. in that apartment complex. Person A, or the first person lives in apartment 0, the next person lives in apartment 1, the next person lives in apartment 2, or so on. It's just a collection of data. But they have to be of the same type in this language. If you declare it as an array of ints, then you better only try to store ints in it. You better not store, strings and floats and stuff like that. And the values are stored in adjacent memory locations, meaning that array access is very fast. It's very easy for the program to access all the elements in the array because they're stored contiguously in memory. They're declared using that special square operator. Not square, but the square braces. So this definition, you give the data type, you give the array a name, and then to tell the compiler that it is an array, you follow the name with a square brace. And then you put a number in there to indicate how long the array is supposed to be. It's got 5 elements now. First element, second element, third element, fourth element, fifth element. If we're going to give them numbers, that's element number 0, 1, 2, 3, and 4.
What all data types can you use?
Any kind that you can declare. If you make a custom data type that's going to contain, an element of the periodic table, and so each element of the periodic table has a name and an atomic weight or whatever, you could create an array of elements. Or if you've defined a class called people, you could declare an array of people or whatever, or an array of weapons for your World of Warcraft character. It can be anything. It's just that once you define it, you can only store data of that type in that specific array. So here, this declares an array of ints. That means that every element we assign to it, it better be an int. It won't be able to accept anything else. So, in this definition here, int is the data type, tests is the name of the array, the thing in the square braces is known as the size declarator. I knew an interior declarator. No, I'm kidding. It shows the number of elements in the array. And the size of the array, in terms of bytes, is the number of elements times the size of each element. Other languages do not care a bit about the size of the array in terms of the number of bytes. In other languages, the size of the array is the length of the length of the array. So the size of this array would be 5. However, in C++ terminology, we would say that the size of this array is 5 times however many bytes are in an int, which I believe are 4. So it would be 20 bytes long. So the size of the array, as we mentioned, is the total number of bytes allocated to it. It's the number of elements times the number of bytes for each element. Since an int is a 32-bit value, which is 4 bytes long, since there's 8 bits in a byte, then something that has 5 bytes in it is actually 20 bytes long. It's just 20 bytes in your program that's allocated to storing that array. So if you create an array that's 1,000 elements long, and it's 1,000 ints, well, an int is 4 bytes, so it would be 1,000 times 4. So that would use up 4,000 bytes, or about 4K. Now, is that a lot? Well, not really anymore. It was certainly a lot in the, in the 70s when you had your Commodore 64 or whatever that had 64K. The maximum you could allocate would be, you knew that your array was going to be less than 64,000 bytes. Nowadays, we have gigabytes of memory and virtual RAM. Okay. The size declarator. Usually you create a constant and then declare your array to that size. The reason you do that is, like I said, to process these arrays you have to use loops, and you have to make sure that your counter doesn't go past the end of the array. This is an array of length 10. We better not ever let that index value get to 10, because the highest number we can get to is 9. If we try to get to 10, at best we'll get an exception error. At worst, we'll be reading data that's unformatted, or we'll be trying to change data that's not part of our program. So we have to know that value 10. Here, we're using a constant to let us know how many values are going to be stored in that array. So in here, I'm going to wipe out everything we've got in here. looks vaguely important.
So how exactly is an array different than a list?
A list is, well, it depends on what language you're coming from. You're coming from Python or Java, then an array, or even a C++ library, then a list is what's known as a dynamic data structure. An array, once declared, is fixed. You can't make that array that was listed of length 5 ever be more or less. But a list is what's known as a linked list structure. A list has a whole bunch of methods that could be called so that you could sort that data, or you could search in a specific element, or you could remove elements from the middle of it. So
can you remove and replace elements in an array?
you can replace elements in an array. However, you cannot delete from the middle without going through a lot of rigmarole. For example, if I wanted to delete element 4 here, you know what I would have to do? I would have to wipe this one out, and then I would have to copy that one into that one into that one, and all the way up, which doesn't look hard if you have 10 elements in the array, but if you have 10,000, and you have to shift up 9,000 of them because you wanted to replace, element 1,000, it's a pain. So dynamic data structures make better use of memory in terms of allowing you to change and insert into it. You could insert, 3 different values here, and then they would all, renumber themselves appropriately, whereas that does not happen with an array.
Can you append?
Pardon?
Can you append to an array?
You can append,
Or the end of it?
but if you go past the last element number, you're going to be in trouble.
Where the spaces, you're not going to be able to make a 9.
Yeah, an array is fixed length, and if you ever try to add an item past the end of it, you're in trouble. Okay, so I'm going to create a new program, and we will kind of show appending data to an array. New project. Very good. I'm glad y'all are asking questions about this. It's like this is an incredibly important topic, and we're getting to it only the last few weeks of class. Okay, so int main return 0, whatever. I'm going to declare an array of strings. String. I have to give the type, and then I give it a name, and then I give the array declarator with the size. So I'm going to say that this is an array called names, kind of like what we were doing up there, or words, and I want 10 words. Let's print out those strings and see what we get. Let's write a little loop. For int I is equal to 0, I is less than 10. I'm having a hard code 10 because I didn't declare a constant named 10. I++, and I want to print out the word at that specific value. Cout words number I. So as I iterates from 0 up to 9, it'll print out our words. We don't have any data yet, so I'm really curious as what it's going to print out. Build static. Well, it printed out nothing. That's okay. Why don't we print out I as well? And it printed out 0 through 9, and it's not indicating that there's any data in it, and that is correct. So what if before we started doing that, we started assigning values? Words number 0 is equal to the design process. Words number 1 is equal to Necronomicon. All right. Word sub 2 is equal to Pac-Man. There we go. Now we've added 3 things to the array. Now that is not strictly an append, but we're assigning values to it sequentially. And so when I run it, items 0 through 2 are going to have what we assigned, the design process, Necronomicon, and Pac-Man. The rest of them are still unassigned, so they're blank. I could keep going like that.
What is variable
I is an index counter. You see how we're referencing element 0 there, and 1 there, and 2 there? Well, if I wanted to print this out, I would have to print out words sub 0, words sub 1, and then words sub 2. But instead, I'm going to use a counter. And counter starts off at 0, and it goes all the way up to, but not including 10. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, printing out the array at that specific position. So it'll print out the design process.
Almost any source code you see. Most people use that.
So is that making sense?
Yes, I had a question. For, you said you couldn't find like the size of an array.
Correct.
I don't know if it always worked, but it always worked for me. I do like, see out word, size of words and then divided by size of.
You could calculate it that way. You could say size of, and then give it the variable name, and divide it by the size of the string. You're correct. But I really want to get people used to the idea of declaring it as a constant. So what I would do to make this code a little bit better is I would declare an int that was the max size of the array, words length is equal to 10, and then I would use that everywhere in my code where I wish to reference the length of the array. So this array is 10 words long. My for loop will count up to but not including 10 because it starts at 0 and goes to 9. There we go. Now I'm going to write a while loop that lets us enter data into this array. It's actually going to look very, very, very similar to this. It's not going to be a while loop. It's going to be a for loop. So let's CIN and say, please enter a word. Please enter a string. Please enter data. Whatever. And then we will let them type in a value. I'm just going to call that string S. Why am I making it a string? Because it's an array of strings. So we have to store it in the same data type. Yeah, that's C out. Herpaderp. There we go. This will let us enter 10 values. I'm going to shorten this array list so that it's only 4 items long. And then when we're done with it, we're going to print out our array again. So that's a data entry loop. It's hard-coded to go from 0 to 1 less than the end of the array. Please enter data. Hello. How are you? And since I'm using CIN, it's only wanting one word at a time. I didn't use getLine. Let's try getLine instead.
And that input is stored in the array?
That's correct. Each one I'm typing, well, I didn't store it in the array. You're very clever for noticing that. All I did is I stored it in a string, and then I forgot to copy that into the array. So, good point.
So what do you have to do to mitigate the risk of buffer overflows?
Don't use arrays. Use an abstract data type. For example, there are character arrays, which in C, the original C language, were the only way you could store strings, and they had a fixed limit. However, a string is an abstract data type that can hold, a string of any length. And so CIN arrow string is a much better way of allowing data entry than CIN into a character array.
So you should, as a general rule, you should never allow user input to be stored into arrays.
You can store data into arrays, but you want to make sure, if at all possible, to avoid arrays of characters. And in this case, there's no problem with the code that I'm writing here once I get it.
Types.
And right, and the reason for that is that a string is a safe data type, and so I'm reading into a string, and I'm limiting the number of strings that I'm allowing them to put in there. So you just have to make sure that that the length of the data that they're entering is not too much for that specific data type, and that the number of items that they're adding to the array does not exceed the size of your array.
Okay,
And you can do those with if statements or whatever if you have to.
okay.
Okay, so I've read the word in, and now I need to store it into the array. My array is called words. I'm going to store it at position I, and I want to assign it the value of the string that I just read. I lost my cout statement. I had a cout statement at one time.
So would the best time to use that be like if you wanted to give like attributes to something like height, width, length, or something that was like always going to be the same?
Well, as long as it's of the same data type, yeah.
Yeah.
Yeah. A list, if you need to store something that's of disparate data types, like you need to store their names and their ages, then you wind up either creating a data type that can hold both the name and an age, or you use two arrays, and those are known as parallel arrays. You say that the first array is an array of names, and the second array is an array of ages, and they're linked by their index number. So that name sub 0 is associated with age sub 0. So if you said Jeff and he's 34, then name sub 0 would be Jeff and age sub 0 would be 34. And then name sub 1 would be Eric, and age sub 1 would be whatever we said the age was in. Does that make sense?
Yeah.
Okay, cool. And another reason I don't recommend that people calculate the size of the array and then go out to that is because if you're dealing with a partially filled array, you want to keep track of how many data elements are actually in the array. If they only enter, 1,000 bits of 1,000 pieces of data, and it's up to a maximum length of 2,000, then when you're printing it out, you probably only want to print out the first 1,000 records. Don't know if that makes sense. Okay, so enter some data. George of the Jungle. Best movies ever. Okay. Star Wars, The Force Awakens. Oh, don't do that. And then the next movie, Star Wars, The Force Goes Back to Sleep. And there we go. Conveniently, it's only accepting the first word. I can't actually say what it's doing there. That's not what I typed in at all, is it? Interesting. I think I'll change it to just being an array of ints. Oh, I see what I did. After using getLine to read in an entire line, then I use CIN. You don't mix the two. Okay, there we go. This should work. Bob, Sam, Joe, and Bill. It prints them out. Element 0 is Bob, element 1 is Sam, element 2 is Joe, element 3 is Bill. And what a partially filled array is say we offer them the option of bailing out of data entry early. We said, if you enter quit, some sentinel value, then stop adding. Well, we would need to keep track of how many data elements we have added because the array is not completely filled. And we would not want to print past the last piece of valid data that we had entered. Okay, make this a slightly better example. Space Invaders will be our third word. There we go. Now we print them all out, and now we're going to write a data entry loop to fill the array, and now we're going to print it out again. So accessing array elements. I've already shown you how to do that. Each element in the array is assigned a unique subscript. starting at 0, the first element is element 0. 1, 2, 3, 4. And so the array is of length 5, then you can access elements 0 through 4. Let's see what happens if we try to access element number 5. I'm going to change one of my for loops. Or let's copy data into it at the wrong position. Okay, the array is only 4 elements long, so I should not try to add a 5th element, but I'm going to. Words for is equal to the 5th element. All right.
You can multitask.
All right, and it blew up. It said a problem caused the program to stop working correctly. Please close the program. That's because it's compiled in debug mode. If we compiled it for release mode, it might not even catch that, that we access past the end of the array. Let's try to print out past the end of the array. So instead of making it less than words length, I'm going to make it less than or equal to words length. So it's going to try to access the 5th element in the array that does not actually exist. Joe, Bob, Sam, Jill. And it blew up again. A problem caused the program to stop working. That's the best case for when you access an invalid element number past the end of out of bounds error, past the array index. Okay.
What's the worst case?
That it keeps running, but that you've accessed memory that you're not expecting to let it access, that's not formatted to be an array, and so if you try to write changes to it, you may be changing other data in your application, or even worse, perhaps modifying bytes that are in the executable portion of your code to make it do other things.
Interesting.
So the last element, subscript, is n minus 1 if n is the number of elements in the array. This array is of length 5, so we can access 0. The last one we can access is 4. Array elements are used just like regular variables. Here we're going to assign element number 0 the score value of 79. And so when we print it out, it's going to say 79. And then we're going to ask from the input for a value, and we store that in array index number 1 in the tests array. And then we can print out or add up element number 0 and element number 1. So what it would be 79 plus whatever the user typed in that was stored into element with index value 1. Arrays must be accessed via their individual elements. We can't do this. See out all of the elements in the array. If this was an abstract data type, a dynamic data type like a list or vector, there's all sorts of different terms for them, then you might be able to get away with something like that. It might print out all the elements in that specific list. But arrays are a little bit more primitive in this language, so they don't have methods associated with them that would convert them to displayable data. So here's their version. The player asks for the number of hours worked by 6 employees. It stores the values in an array. Here they declare an array called number of employees. Excuse me, they declare a constant called number of employees. They know that that's the length of the array, and they better not ever access element 6 or greater. You can only access elements 0 through 5. Then it gets to the data entry part. It says, please enter the hours worked by, and then it has a constant here, but it's going to, say 6. Hours worked by 6 employees. And then it's got 6 CIN statements, reading them in sequentially into elements 0, 1, 2, 3, 4, and 5 of the hours array. Then if we wanted to print them out or we wanted to sum them or something, we could use a while loop or a for loop in order to print them out or to sum them. Go away. All right, going to create a new value, new array. Int temperatures. Let's declare a constant called months, and that's going to be equal to 12. Now we're going to use another input loop that looks a lot like this one. For int I is equal to 0, that's the index value. I is less than months, I plus plus, and then we're going to tell them to enter the rainfall for that specific month, no, the temperature for that specific month. Cout, enter temperature for month, followed by I. Let's see if that works or if I need to convert that to a string. And then we would read this into the array at that specific element. Temperatures at element number I. Then we would use a for loop to print all that out. For int, this is getting real repetitive, but that's because we're showing the same concept in different aspects. I is less than, oh, I need to correct that so it won't give me an error every time I do this. Okay. I is less than what? The number of months. I plus plus. Now let's print out that month number followed by the month number, which is I, followed by the temperature, followed by the temperature for that specific month, followed by an end of line. Because I called it temperatures.
In your output, there's no I plus 1. There's no 1, 0.
Yes, I was going to do that. When I run this, it's going to print months 0 through 11. And humans don't like seeing ranges that start with 0 rather than 1. So I'm actually going to go back and to change this to say it's month number I plus 1. Because we think in terms of month number 1, January, month number 2, February, and so on, all the way out to month number 12, December. But the computer thinks of it in terms of month number 0, all the way out to month number 11. So when I print out the month, I'm going to add 1 to it to make it look better for humans. All right, enter some data. Joe, Bob, I need to comment this input loop out. Sam, Bill. All right, enter temperature for month 0. I thought I changed that. No, I did not. Not there. Only on my output loop did I, not in my input loop. Okay. There. For temperature 1, January, temperature was 10. February, temperature was 80. March, the temperature was 120. Global warming has really kicked in. And then 100, 90, 80, 40, 30, 20, 10, 20, 0 in December. And there we go. It prints out all the temperatures that we stored in that array. Now we could process that and we could get the average, or we could get the sum. Well, you have to have the sum in order to get the average. To get the sum out of this, we would use another for loop, but we would declare a sum variable beforehand. Let's declare it of type double rather than float, although there's no specific reason for me to think to do that. So I'm going to call it sum. I'm going to set it equal to 0, and each time we go through, we want to add on to the sum the value of the array at that specified index value. So sum is going to increase as we go along. I'm going to print the sum out as we go along just so that we can see that number increase. And then we're going to print out the sum of the temps is followed by that sum value. There we go. No, please remind me to get rid of that. Okay. Temperature for month, I'm going to have to change this so that there's like only 4 months in a year. 20, 30, 40, 100, 200, 10, 20, 30, 40, 50, 60. There we go. So here's our temperatures, 10, 20, 30, 40. Here's our sums. Well, after the first iteration, the sum was 10. After the second iteration, we added 20 to it, so our sum became 30. After the third iteration, we added 30 onto that, so our sum became 60. After the next iteration, we added 40 to that, and so 60 plus 40 is 100. So the sum was a tally. It continued going until we hit the end of the array, and the sum of all those values was 630. So if you're going to write a sum loop, you declare your tally variable outside of the loop, and then inside your loop that's iterating a counter of some kind, you add on to that tally variable, that sum value, the element at that specified index value. So now we could print the average as well very easily, because the average is what? It's the sum divided by the length, by the number of data elements. So average is followed by sum divided by months, which is 12. Not anymore, I'm changing it. Our new counting system only has 4 months in it. There we go. Okay, so 80, 90, 100, 110. Those are our 4 temperatures. Here's the sums as they get added. 80 plus 90 is 170, plus 100 is 270, plus 110 is 380. So the sum of all those temperatures is 380, and the average is 380 divided by 4, which is 95. So you can access the elements with what's known as a constant or literal subscript. That's where you just hard code a number there. And that's how I assigned those first 3 values, those first 4 values when I put Pac-Man and Necronomicon and stuff like that in there. I was specifying the index value with a hard-coded number, with a constant, with a string literal, with a numeric literal. Or you can use an integer expression as a subscript. You say I is equal to 5, and then you see out tests sub 5. So that would print out the 6th element of the array, assuming that array element 0 is the first. Using a loop to step through an array. We've demonstrated this. We set a constant equal to our array size. We should be calling it length. Then we have an array of numbers that's allocated to have that many elements. And then we have a for loop. Instead of using I, they're using a variable called count as their iterator, as their counter. So count is equal to 0, count is less than the array size, count plus plus, and this is assigning every value in the array the value 99. People write loops like that a lot to initialize the array with the data value that they want. Let's see if that's necessary. We're going to create an array of ints, but we're not going to put any data in it, and then we're going to try to print them out. I'm going to put that code up at the top so I don't have to keep entering the data. Okay, so const int, I don't know, in length is equal to 10. We're going to have 10 elements in this array. And then int, we're going to call this nums out to that array length. And now let's write a for loop that'll print them all out. Same kind of business. I is equal to 0. I is what? Less than what? In underscore length. I plus plus. And we want to print out that element, nums, at position I. Notice we haven't copied any data into the array at this point. We just declared it. When we run it, it's got these horrible values in it, negative 85 billion or whatever that is. That's uninitialized data. When you declare the array, it doesn't necessarily wipe the data out and set it all nice and neat to zeros. With the strings it worked, but that's because a string is not a primitive data type. It's not just a numeric, value. It's a class, and the class knows how to reset itself when you create it. An array of numeric values, ints or floats or doubles or whatever, does not know how to initialize it as you create it. And that is not true in a lot of other languages, but it's certainly true in C++. So if I wanted to wipe all of these data out and just give them the value of 0, I need to write a loop that will do that. So I guess I can do it after I print it out. The for loop header is going to be the same, so I'm just copying that and I'm pasting it. But then in here, I'm going to say nums at value I is equal to 0. And then when I print them out again, it's going to print out 10 zeros. Much better. So this is initializing an array to 0. All the elements of the array to 0. So we were getting that horrible negative 8.5 billion, and now we're getting nice clean zeros all the way through. So when you declare your array, if it's an array of numeric values, it's really not a bad idea to run through it and initialize it to 0. We will see that there are other ways of initializing your array. It should be mentioned very soon. A closer look at the loop. The variable count starts at 0. So the variable name is the name of your iterative variable. That's going to be the index value into your array. And then this initializes it to the first position in the array, which is 0, of course. And we tell it to stop before it hits the length of the array, because you can only go out from 0 to n minus 1, the length minus 1. And then each time you go through, you want to access the next element, so you add 1 to your index variable. Default initialization. If it's a global array, which means it's declared outside of int, all the elements are initialized to 0 by default. If it's a local array, all the elements are uninitialized by default. Now, to me, this is crazy. The fact that the behavior of the array creation differs based on where you declare it is nuts. So if this array right here had been declared outside of main as a global variable, then we would not have had to initialize it to 0. So by moving this declaration up here above main, and then I run it again, we'll see that even the first run through of it, whoopsie. Oh, I already have like 20 copies of the program running, so it's complaining about saving the file. There we go, Just by moving that variable declaration and making it a global variable, it changed the behavior of the allocation of the array to wipe out all the data as it is being allocated and reset it to 0. So we no longer see that garbage data of negative 8.5 billion. So that's one way to get the data initialized. It's not really the best way. You shouldn't use global data unless it has a reason to be global. And what is global data? It's data that all of the methods, all of the functions that are defined in this particular file can access. It's not local to any one function. It's shared between all the functions in this file. No bounds checking in C++. When you use when you use a value as an array subscript, C++ does not check to make sure it's a valid subscript. So if the array is only 4 elements long and I try to access element number 100, bad things are going to happen. In other words, you can use subscripts that are beyond the bounds of the array. The results are mixed. Be careful not to use invalid subscripts. You can corrupt other memory locations, you can crash the program, you can even lock up the computer, cause elusive bugs. Off by 1 errors. Off by 1 is when you use array subscripts that are off by 1. So, for example, in that array of monthly temperatures, if I told the user to enter the temperature for month 1 and then I assigned that into element 1, and then I did the same thing for month 2 and I copied it into element 2, keep going down the list. I asked for month 11 and I copied into the array at position 11. Then I asked them for the temperature at month 12. Well, that's passing into the array. And that's why we did that +1 business when we were displaying our loop. So here's another example of an off by 1 error. They initialize the count to 1 rather than 0, and they go less than or equal to the size rather than less than the size. The way to correct this loop would be to say your starting point is 0 and you can only go up to, but not including, the size of the array. Array initialization. Here is a cool little syntax for initializing an array with a preset series of values. This says I'm going to create an array of 5 ints, and I want those ints, I want that array to be filled with the values 79, 82, 91, 77, 84. The values are stored in the array in the order in which they appear in the list. So that's element number 0, that 79 is. 82 is element number 1, 91 is element number 2, 77 is element number 3, and 84 is element number 4. The initialization list cannot exceed the array size. So if I went back here and I made this 4, that's bad news, because now, you know, we could only have 4 elements in our array list, initializer list, rather than 5. Let's see what happens if we do that. I want to see the error that comes up. It's underlining it. It's nice that it's actually giving us an error. Here we go. It says error, too many initializer values. The compiler is smart enough to check this value and the count of the things between the curly braces to make sure that this value does not exceed that. But what happens if you put in too few? You know, we have 4 here, but what if we only put in 3 pieces of data there? What's the 4th piece of data going to look like? Any guesses? Is it going to be that negative 8.5 billion, or is it going to go ahead and initialize it to 0?
Garbage.
Logically, it should be garbage. In actuality, it's going to be 0. Yeah, it's 0. Once you start initializing, if you don't hit the end of the array, by the time you hit the end of your initializer list, the rest of them are initialized 0. So you see this loop that I wrote down here to initialize all the values to 0? I could skip that if I just declared my array like this. If I had said like that, then all of the array would be wiped out and set to 0. And I could have skipped writing that initializing loop here. So this initializes the first 3 values in our array to 79, 82, and 91. 79, 82, 91. Any further remaining elements in the array will be set to 0. So in this case, since the size is 4, and we initialize 3 values, the 4th value is set to 0. You wind up doing this more often than you would expect. This is an array with an initializer that contains the number of months in a day, in the number of days in a month. 30 days, November, April, June, whatever, no. So January is 31, February is 28, March is 31, April is 30, May is 31, June is 30, and so on. And the reason you would do that is so that when you were allowing data entry, you would make sure that they did not type in a bad value. You know, that I was born on October 42nd. However, this does not take into account the fact that there are leap years. So the value for February is a more complicated calculation than just hard coding a 28 in an array there. So if the array is initialized with fewer initial values than the size declarator, the remaining elements are set to 0, and that's what I illustrated. So our array here is 7 elements long. We give an initializer list that's 4 elements long. So the first element's a 1, the next one's a 2, the next one's a 4, the next one's an 8, and the rest of them are all wiped out to 0. Implicit array sizing. We can determine the array size by the size of the initialization list. Int quizzes, and then we don't put anything here. And then it calculates, or the compiler counts the number of elements in the initializer list and makes the array 4 elements long. If we put 10 numbers here, or 12 numbers here, then we'd treat it as though there were 12 there. So you must use either a size declarator or an initializer list at array definition. You can't just do this. This is not valid code. You can't go in and go, I'm going to make a new array. It's going to be an array of floats. And I don't know how long it's going to be. And there we go. You know. Well, for one thing, floats is not valid, but there, you know. It wants either an initializer list or a size declarator. So I either have to go in and fill this in, or I have to start giving some numbers here. Like that. Now that is an array of length 3. Okay, what have I done wrong? I thought I had to, I'm going to make this, oh, I hadn't added a decimal. Okay, anyways. Okay. So now if we printed out the contents of that array, it would be what we initialized it to, and we could access elements 0 through 3. Well, then the question arises, how do I know that there are 3 elements in it? The range-based for loop. C++11 provides a specialized version of the for loop that simplifies loop processing. Now, this originated in Java and was eventually stolen and put into C++. The range-based for loop is a loop that iterates once for every element in an array. The range-based for loop automatically knows the number of elements in the array through magic. You do not have to use a counter variable. You do not have to worry about stepping outside the bounds of the array. So here's what the syntax for a range-based for loop looks like. It's quite different than the syntax for the other kind of loops. But if you're going to be a Java programmer or if you're going to be a C# programmer, you may as well get used to this because you will see this all the time in those languages. So here I had declared an array of floats. Now I want to print those floats. I would say for every float that is in my array, do something with it. Print it out or something. Now that is in contrast to the other way of doing it, where I had to declare a counter. I was my counter. I had to set it equal to 0. I went as long as it was less than 3, I++, and then I printed out cout, and I printed my array, farray at element number I. Maybe that doesn't look much more complicated, but this is actually a much cleaner way of going through it for 2 reasons. Name 2 differences between that for loop and that one that kind of leap out at you, if any. Well, did we have to specify 3 in this loop? Somebody say no.
No.
Right. This ranged for loop automatically knows the number of elements in the array. The other difference, we don't use a counter. Every element in the array is successively copied into that temporary variable for you to use. So a more exact analog of this would be to do this. F is equal to farray at position I, and then print out element F. That is just about exactly how that ranged for loop works. This code is equivalent to this. Well, I have to declare that data. There we go. See? Looking a little bit uglier. This is the cleanest syntax by far for stepping through an array. So the way you use it is you use the for keyword, of course, and then you give a data type, int, long, float, double, string. And then you give a variable name, which is your range variable, which is the temporary variable which each element of the array will be copied into. And then you give an array name. And then you put a code block after the for statement. So we've had, obviously, a great many print loops here. Let's find one of them. One of them that's not very complicated. Yeah, the summing of the months. We could rewrite this summing of the months to use a for loop. Excuse me, a ranged for loop. In C# it's called a for each loop. So if I say for each, I mean a ranged for loop. Okay, so for every, now what kind of data type is our months declared as? It's declared as ints. So for each int in the array of temperatures, add that to the sum. Sum plus equals temp. And then we could, if we wanted to be exactly the same as the other one, we would use cout to display our current sum. Now the code will work exactly the same, but it was a little bit easier to write. Didn't take nearly as long to type as it does to do all of that. What is the drawback of using a ranged for loop? You can't modify the data as you're running through it. You know, in our initializing loop way up at the top, I initialized every value of the array to 0. I couldn't do that with a range loop because I'm just getting a copy of the variable. You know, the first element is copied into a variable called temp. If I change temp, so what? The array isn't modified, just that temporary variable. Same for this place up here. The first place I use my range loop. Right there. This is a temporary variable that receives a copy of each value in succession, of each element in succession in that array. So if the first thing I did or the last thing I did is to change it, you know, if I decided I'm going to destroy my data for some reason and set f equal to 99999, it doesn't care. Ain't nobody got time for that. It's just a temporary variable. Yeah. So you cannot change the values of the array while you're stepping through it with a ranged for statement, as you can with the regular for statement where you have a counter. And the reason why is because you don't have a counter. You're not accessing the array elements themselves. You're accessing a copy of each element in turn that get copied into that variable. Oh, neat. I forgot this. You actually can. This is different from the other languages, C# and Java. C++ has to be all macho and do things that no other language can. So once they implemented for each loops, they added this ability to actually modify the data. And do you remember when we talked about reference variables? A reference variable is a way to pass data into a function so that that function can actually modify that value. So this will be a reminder of that because this is incredibly important even though I haven't made a homework assignment over it. I'm going to write a function called changeMe. And it's going to take a reference variable. And it's going to change that value to something. Now since that's a reference variable, if I call changeMe with an integer, you know, I set i's, well, I better not use I use that all over the place. So I make a variable called age, I set it equal to 10, and then I call changeMe, and I pass age into it, and then I print out age. Age is now going to be equal to 999. Let's write a version of this that doesn't use the reference symbol, the ampersand right there. And we will find out that even though we're setting it equal to 999 here, it doesn't change it there. Well, what do you know? Why are you complaining at? Oh, because I have two versions of it. So changeMe1 is a version that accepts a reference variable as a parameter. changeMe2 does not accept a reference as a parameter. So data is just a mere copy of whatever got passed into it. Whereas if you declare it with the ampersand, then this variable is actually a reference to the original variable. Just like if you've heard the word pointers, it's a pointer to the original variable. So if you assign a new value to that variable, it overwrites the variable that you passed in. So after we call change me1 and we print age, it's going to equal 999. Now we're going to reset it back to 10, and we're going to call change me2, which does not use the reference data type. And so even though it gets set to 999 here, it's only modifying a copy of the data. The original value, the original variable age, is untouched. And so we see, oh, well, what do you know?
Change me too.
Yeah, thanks. I was about to get quite irate. There we go. The first one was able to change the value of that variable. Age actually changed to 99 because it's a reference variable declared there. Here, it did not get to change the variable because its parameter is not declared as a reference. And so it turns out that in a range loop, you can declare your temporary variable as an ampersand, and then it is not just a copy of the array element at that position, it actually is the array element at that position. So now that I have this little float array, if I wanted this code to actually work and to reset all of those values to 99999, I would declare this with an ampersand in front of it. This means that f is not only a temporary variable that gets a copy of each element, but that it's a pointer, that it's a reference to every element in the array in turn. And so now, if I print the variables again with one of these guys, they will all be 99999. Or not. Oh, again, I left a copy of it running. So there we go. The second ranged for loop was able to change the values of the data values, change them to 99999. And the reason that worked is because we used a we used a reference variable as our ranged for loop counter. Right there. We used an ampersand there. So in here I'll put a comment. This would not work if we had not declared f as a reference variable. Since we did, f is not merely a temporary variable getting a copy, but it is a reference to that actual element and can be changed. All right, we're about done. And arrays and array lists and all those data structures that are more dynamic than arrays but contain a list of data are just crucial to programming. If you're going to write a video game, you're going to have a series of sprites on the screen that you're going to be moving around, all the spaceships or all the characters running around on the screen. Each one is going to be a separate element, but in order for your program to update the position of each one of them, they're all going to be stored in an array or an equivalent data structure, so that your program will go through and update the position of each one, and then it will go through it again and display each one. Just like these little for loops, except with much more complicated code behind them. So arrays and loops are the key, essentially, to writing programs, really. Just want to make sure that that actually worked. I forgot that I'd made this array only 3 elements long, and so the appearance of it was confusing me. All right, guys. We didn't really do an in-class assignment. If you were typing along, that's wonderful, but we didn't have an organized one. Yes, sir.
I had a question not pertaining to your class. Just about all files end in an even number of bits, like a multiple of bytes, right? like, they'll all be, like, if I'm reading a file, it'll never be an odd number of bits.
That's correct. Every file will be a multiple of the word size of the system. So if the word size of the system is a byte, which it is on all these computers, then you'll never get one that's 7 bits or 9 bits or whatever, it'll be 8 bits or 16.
Thank you.
Sure.
So, sorry, I was really naive of me not to know that answer.
No, that's totally fine.
I'm nearing the end of that one project I told you about, and so I just wanna make sure it runs correctly before I, finish writing it.
That loop system
Yeah,
on
I
there
like
still
to
doesn't
make
have
sure
any
that
instructions on it.
Let's do that right now.
It's like I bought off all the cops. Yeah.
You're free to beat me.
Yeah, they owe me a favor.
I hope you don't do it too hard, but let's
Yeah, so
get this.
now I get